ALHS Online Learning. Math 9, Extra Practice 2.5. Number 1, write each expression as a product of powers or a quotient of powers. If you have a power where the base is a product, you can apply the exponent to both factors in the base. As an example, if you have 3 times 4 to the power of 5, the exponent of 5 would get applied to both the 3 and the 4. It helps to think of it as repeated multiplication. 3 times 4 to the power of 5 is equal to 3 times 4 times itself 5 times. Next, we can remove the brackets. And now we can regroup equal factors. We have 3 times itself 5 times here, and we have 4 times itself 5 times here. Now we can rewrite the repeated multiplication as a power. 3 to the power of 5 times 4 to the power of 5. The easiest way to solve this is to apply the exponent to both factors in the base. 3 times 4 to the power of 5 equals 3 to the power of 5 times 4 to the power of 5. This is an example of the law for power of a product. There is no difference if you have a power where the base is a quotient. You can apply the exponent to both the dividend and the divisor in the base. As an example, if you have 5 divided by 6 to the power of 3, the exponent would get applied to both the 5 and the 6. It helps to think of it as repeated multiplication. First, we need to remember that whether we use the division symbol or fraction form, we can still use repeated multiplication. So the division symbol or fraction form. Now we can rewrite the repeated multiplication as a power. Here we have the repeated multiplication. So it's 5 over 6 times itself 3 times. We can rewrite the fraction to have repeated multiplication, 5 times itself 3 times on the numerator, and 6 times itself 3 times in the denominator. And when we rewrite it into single powers, we have 5 to the power of 3 over 6 to the power of 3. Now we can leave this as our final answer, but we could also rewrite this with the division symbol instead of fraction form. So as we can see right here, we have 5 to the power of 3 divided by 6 to the power of 3. The easiest way for us to solve this is to just apply the exponent to both numbers to get 5 to the power of 3 divided by 6 to the power of 3, or in fraction form, we would apply the exponent to both numbers and get 5 to the power of 3 divided by 6 to the power of 3. This is an example of the law for a power of a quotient. 2. Write as a power. When you have a power raised to a power, you can rewrite them as a single power. Sounds confusing, but as an example, if you have 3 to the power of 2 all to the power of 4, so we have one exponent here, one power, with another exponent being applied to this power right here. It helps to think of this as repeated multiplication. So 3 to the power of 2 all to the power of 4 can be thought of as 3 to the power of 2 times itself 4 times. Now that we have 3 to the power of 2 times itself 4 times, we can use the exponent law for the product of powers that we learned about in the last unit. 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2 times 3 to the power of 2 equals 3, and we add the exponent of 2 all 4 times, which gives us 3 to the power of 8. The easiest way to solve this is just to multiply the exponents. So we have 3 to the power of 2 to the power of 4. We take these two exponents and we just multiply them, like we see right here. So 3 and the exponent 2 times 4 gives us 3 to the power of 8. This is an example of the law of a power of a power. The number 3, simplify then evaluate. When you're asked to simplify then evaluate, you need to use all of the exponent laws from this unit and the last unit in order of operations to change each expression into standard form. As an example, if we have 3 to the power of 2 times 3 to the power of 1 in brackets all to the power of 2, we need to use the exponent law for a product of powers from the unit 2.4 and the exponent law for power of power, then use the exponent law for power of powers to get a single power, and then we can solve for standard form. I know, sounds complicated, but let's just follow this. So first we need to use the exponent law for a product of powers on the two powers inside the brackets. So we have 3 to the power of 2 times 3 to the power of 1, which we know we can use to become 3 to the power of 2 plus 1, which then gives us 3 to the power of 3. And this power is still all to the power of 2. But now this question looks a lot like the question we just solved in example number 2. Now we can use the exponent law for a power of a power to get this to a single power. So 3 to the power of 3 to the power of 3 all to the power of 2 equals 3 to the power of 3 times 2, which equals 3 to the power of 6. Now that we have 3 to the power of 6, we can solve for standard form. 3 to the power of 6 equals 729. In another example of simplify then evaluate, if you have 4 to the power of 6 divided by 4 to the power of 4 in brackets all to the power of 2, first we need to use the law for a quotient of powers on the two powers inside the brackets. So 4 to the power of 6 divided by 4 to the power of 4 becomes 4 to the power of 6 take away 4, which would give us 4 to the power of 2. So this power 4 to the power of 2 is still in brackets and put to the power of this 2, which we can now use the exponent law for a power of a power to get a single power. So 4 to the power of 2 would give us 4 to the power of 2 would give us 4 to the power of 2 times 2, which gives us 4 to the power of 4, which we can then write in standard form as 256. Okay. So now, number 4, simplify then evaluate each expression is very similar to the example we just had. However, this is going to take a couple more steps. When you have a larger expression, you will need to follow the order of operations. As an example, when you have 2 to the power of 3 times 2 to the power of 6 in brackets to the power of 2, take away 3 to the power of 7 divided by 3 to the power of 5 in brackets all to the power of 4. Following the order of operations will make it easier to solve. First, we need to use the exponent law for a product of powers and the exponent law for a quotient of powers on the two powers inside the brackets. Remember, whether this is a division symbol or this is in fraction form, we follow the same procedure, just like we saw earlier in the video. So 2 to the power of 3 times 2 to the power of 6 becomes 2 to the power of 3 plus 6. And 3 to the power of 7 divided by 3 to the power of 5 becomes 3 to the power of 7 take away 5. Which then gives us 2 to the power of 9 to the 2 to the power of 9 to the power of 2 take away 3 to the power of 2 to the power of 4. Now we can use the exponent law for a power of powers to get to a single power, or to get to two single powers, I should say. This becomes 9 times 2, and over here we have 2 times 4 because we're going to multiply both sets of exponents, which will then give us 2 to the power of 18 take away 3 to the power of 8. Now we can solve for standard form. 2 to the power of 18 becomes 262,144. 3 to the power of 8 becomes 6,561. 262,144 subtract 6,561 equals 255,583. So I hope that this will help you be able to complete the exercises in lesson 2.5.